Hello guys, in this video we are going to be solving the question that you can see on your screen. It says we should show that the equation x squared minus y squared equal to 74 has no integer solutions. So we first of all begin by recalling what an integer is. So an integer is simply a whole number, a positive or a negative whole number. Now you see that if we actually want to show that this equation has no integer solutions directly, is going to be stressful, because we are going to solve for the values of x and y in the set of integers. It looks a bit bizarre, so we are going to prove, or we are going to show this by contradiction. So prove by contradiction, that's what we are going to do. Now to prove by contradiction, we are going to suppose that there are integer solutions, and then we show that it is impossible, and then we conclude. So suppose that x squared minus y squared equal to 74 has integer solutions. So we have supposed a falsity of the statement. Okay, now if it has integer solutions, that is what we have supposed, we now prove that this is impossible. So if we suppose that it has integer solutions, and then we show that it is impossible for it to have integer solutions, then we are okay that there are no integer solutions, because we have actually contradicted ourselves by supposing that there are integer solutions, and now at the end saying that there are no integer solutions. So now x squared minus y squared, we know this is difference of two squares is x minus y into x plus y. Now if I set, let me say, x squared minus y squared to be equal to f of xy, then our equation becomes f of xy is equal to 74. Now we have already simplified what f of xy is. It means x minus y into x plus y is equal to 74. Now since we suppose that there are integer solutions, it means that, so since we suppose that there are integer solutions, what does it mean? It means that what, my x and y belongs to the set of integers. Now if x and y belong in the set of integers, it means x is an integer and y is an integer. Now if x is an integer and y is an integer, let's see what x minus y is. X minus y for sure is going to be an integer, because we are doing the difference of two integers, and also x plus y is going to be an integer. So we have seen that this guy here is going to be an integer, and this also will be an integer, since both x and y are integers. Now x minus y being an integer and x plus y being an integer, now we know the set of integers, the set of positive and negative whole numbers. So definitely if I am an integer, it therefore means that I am either even or I am odd, according to the definition of what an integer is. If I am a whole number, then I am either I am even or I am odd. So we are going to take several cases and we solve to see if the possibility holds. So case 1, when x minus y is even and x plus y is even. So we take the case when both of them are even. Now x minus y is even means that x minus y can be written as 2 times a certain integer k1. Now x plus y is even, therefore means that x plus y can be written as 2 times another integer. Note that our k1 and k2 all belongs to the set of integers, whether positive or negative. Now it therefore means that f of xy equal to 74 implies 2k1, which is x minus y, and 2k2, which is x plus y, is equal to 74. Now this means that 4k1 k2 is equal to 74. Now we can divide both sides by 4. We are going to get k1 k2 is equal to 74 divided by 4, which is simply 37 divided by 2. So in essence, we are trying to say that k1 k2 is equal to 37 divided by 2. But what is 37 divided by 2? 37 divided by 2 does not belong to the set of integers. So I guess we are now seeing the contradiction in the first case. We know that k1 and k2 are both integers, and definitely the product of two integers will definitely give you an integer. But in this case, we are having the product of two integers k1 and k2 to be equal to 37 on 2, which is not an integer. So we see that 37 on 2 is not an integer, therefore telling us that k1 and k2 are not integers, whereas our definition says they are integers. So that is a contradiction. So you see the first case has worked for our proof by contradiction. Okay, now let's go to the second case. Case number 2. Case 2, when x minus y is odd and x plus y is odd. So when both of them are odd. Now x minus y is odd means that x minus y can be written as 2k1 plus 1, where k1 is an integer. That's the definition of an odd number. Now x plus y is odd. It means x plus y can be written as another odd number, 2k1 plus 1. So my f of xy equal to 74 means that 2k1 plus 1 times 2k2 plus 1 is equal to 74. Remember, k1 and k2 are integers. Okay, now if we open this bracket, we are going to have 4k1 k2 plus 2k1 plus 2k2 plus 1 is equal to 74. This means that 4k1 k2 plus 2 into k1 plus k2 is equal to 74 minus 1, 73. Now we can factor out 2 from here. We are going to have 2k1 k2 plus k1 plus k2 is equal to 73, meaning that 2k1 k2 plus k, remember, yes, plus k1 plus k2 is equal to 73 divided by 2. Remember, k1 and k2 are integers. It means that k1 times k2 is an integer and k1 plus k2 is an integer. Therefore, the addition of the sum of two integers, all of this should give us an integer for sure. But this guy here is not an integer. So that's the second contradiction. So we are good. Now let's go to case 3. Case 3, when x minus y is even and x plus y